Good day, viewers all over the world. I want us to consider further example on partial derivatives. Of course, we have discussed about partial derivatives. That is when we have, for instance, in this question now, we are to show that u of x, y, z is given as x squared plus y squared plus z squared, everything raised to power minus half. We have to show that this satisfies Laplace PDE, partial differential equations. We want to show that when we do this, we are going to get everything to be equal to 0. So under partial derivative, if we want to differentiate u with respect to x, you pretend as if y and z are constants. So this is what we want to show. How do we go about this? How do we go about this? Of course, we have to start from somewhere. So we are going to write u, which is equal to x squared plus y squared plus z squared, everything raised to power half. Everything raised to power half. So if you differentiate that partially, the u, the x, let's start with x. The first derivative, partial derivative of u with respect to x. Of course, what do we get? This minus half will come down. We have minus half. Multiply by, we differentiate this core. We only differentiate for u, this will be 2x. Into bracket, x squared plus y squared plus z squared. Everything, you subtract 1 from this, minus 3 over 2. That's what you get. Okay? This will take care of this. At the end of the day, we realize that, so we are going to get the u, the x, as, I just want to rewrite, minus x all over x squared plus y squared plus z squared, everything raised by 3 over 2. That will be the value. I just try to apply indices. To rewrite that. That's what you're going to get. Okay? I will now go ahead and differentiate this the second time. The square u all over the x squared. That's what I'm going to do. But you realize that the u, the x is in form of fraction. So of course we can apply product rule here. We can apply product rule, but with the consciousness that we are differentiating partially, not totally. So what do we do here? What do we do? No, under partial, the first one will be v squared, will be underneath, because v du, so here will be u, the down one will be v. So we are going to have x squared plus y squared plus z squared, 3 all over 2. This is v. V squared will be what we have there, that is multiplied by 2. This will cancel this. So the formula says that we have v. What is v? The down one. X squared plus y squared plus z squared raised by 3 all over 2. Multiplied by v du. If I differentiate this is x. That will be multiplied by minus 1 minus u, which is minus x, multiplied by, and I want to differentiate what I have here. So if I differentiate what I have here, 3 over 2 will come down. There will be 3 all over 2. Okay. Multiply by, when I differentiate this with respect to x, multiply by 2x into bracket x squared plus y squared plus z squared minus 1 raised by half. That's what I'm going to have. So if I apply product rule, if I apply quotient rule on this, I'm going to get this. Then, of course, this will take care of this. At the end of the day, this minus, okay, I'm going to get minus here, but I want to rewrite it. Minus times minus is plus. So I'm going to get 3 x times x squared. So I want it to be equal to 3x squared into bracket x squared plus y squared plus z squared raised by half. Then minus this, minus what I have here will be minus x squared plus y squared plus z squared, 3 all over 2. All over x squared plus y squared plus z squared raised by 3. So di square u all over di x squared will be given as, let's call this asterisk 1. So we have been able to find the value of di square u we have been able to find the value of di square u all over di s squared. But if you look at the question critically, you realize that even if I go to, if I decide to find the next one, which is di square u all over di y squared, I'm still going to get everything. The only difference is that this place will be y squared because it's the same thing. Why? Because u is given as s squared plus y squared plus z squared, everything raised power minus half. So whatever operation I perform on each of these x, y, and z will be the same thing. The only difference is that if I do for di square y, di square u all over di y squared, the only difference is that this place will be y squared. Every other thing will still remain the same. Every other thing will remain the same. Please, let's look at it very well because it's still the same thing. Okay? So we have gotten the value. I want us to note this di square u. This is the value of di square u all over the s squared. So I want to go ahead and do for y. I want to do for y. It will still be the same thing. I want to do for y, but I believe it is going to be the same thing. So let's go ahead and do that of y. Okay? We have gotten di square u over di s squared. We want to do di square. We want to do di square u all over di y squared now. So let me start with di u di y. I want to differentiate this with respect to y. So what will I get? That will be minus half multiplied by, if I do this, I'm going to have 2y into brackets s squared plus y squared plus z squared, everything is power minus 3 over 2. That's what I'm going to get. Then at the end of the day, I'll get this to be equal to, this will cancel this, I'll get it to be minus y all over s squared plus y squared plus z squared, everything raised power 3 over 2. If you check di u, di y, it's the same thing that we got. The only difference is that I have y here. Okay? That's the only difference. The only difference is that I have y here. So if I differentiate this the second time, di square u all over di y squared will be, if I go through the process that I went through when I want to find di square u all over di s squared, it's the same thing. The final result will only be 3y squared instead of s here now. It's y that I will have here, but every other thing will remain the same. Okay, so this will be into bracket s squared plus y squared plus z squared raised by half minus s squared plus y squared plus z squared raised by 3 over 2. Then everything all over s squared plus y squared plus z squared cube. This will be the value of, that will be as 32. This will be the value of di square u all over di y squared. Just go through the process that we went through in the first case. We are going to get, that's what we are going to get. So we are going to get the same thing. That is what we are going to get. Then that's what we are going to get. So if we now do that of z, it will still be the same thing. The only difference is that we are going to have 3 z squared here. When you go through the same process, we have the same thing. If you go through the same process, we have the same thing. For instance, let me just do it here. If I want to find di u di z, okay? If I want to find di u di z, it's still the same thing. We still get the same thing. So that's as 31, as 32. So as 33 will be di square u all over di z squared. We still get the same thing. We're still going to get the same thing. Okay. Let me just, we are going to get the same thing. Let me show in case of z offset. Let me show that of z. But we are still going to get the same thing. If you follow the teaching properly, we realize that we are going to get the same thing. The only difference is that we keep changing this. This is the only difference. So what is di u di z? In this case now, we consider z. So minus half will come down, multiplied by 2z, okay, into bracket s squared plus 3x plus y squared plus z squared, everything raised by half. Okay, this will cancel this. Then at the end of the day, di u di z will be minus z all over s squared plus y squared here will be minus 3 over 2 plus z squared all over 3 over 2. That's what we are going to get. This will be equal to this. So if we differentiate this partially the second time, what we are going to get will be 3z squared into bracket s squared plus y squared plus z squared raised by half minus s squared plus y squared plus z squared raised by 3 all over 2. Everything all over s squared plus y squared plus z squared. Everything raised by cube as 33. That is what we are going to get. So if you do it correctly, that is what we are going to get. That's what we are going to get. Okay. So if we now look at the three equations that we have on the board, asterisk 1, asterisk 2, and asterisk 3. If you add all the three equations together, we are going to get that Laplace PDE. That's what we are going to get. Okay. So adding. So from there now, we now say that adding asterisk 1, asterisk 2, and asterisk 3. So what will happen if you add everything together? If you add everything together, we have this plus this plus this together. We realize that del square u all over del x squared plus del square u all over del y squared plus del square u all over del z squared will give us, if we add all the three together, the only difference that you have here, this is half. Okay. If you add all these three together, look at everything is the same. The LCM is the same. When you take the LCM, is the same. If you take the LCM is the same, then this and this, we are going to have everything. Just what we are going to do is that we are going to add all the numerators together because the LCM is the same. Now look at the numerator. This is 3x squared, component of this, plus 3y squared plus 3z squared. So at the end of the day, you realize that we have 3 into brackets s squared plus y squared. This is what I'm trying to say. If we add all these three together, if you add 1, 2, 3, if we add everything together, adding these three together, what are we going to get? If we add everything together, this is what we are going to get. If we add everything together, this is what we are going to get. Let me write it here. If we add everything together, we are going to have 3s squared plus y squared plus z squared multiplied by 3s, multiplied by s squared plus y squared plus z squared raised by half minus, if you have all this minus this together, we have 3 into brackets s squared plus y squared plus z squared raised by 3 all over 2 all over s squared plus y squared plus z squared, everything raised by cube. So if this multiply this is raised by 1, this is raised by half. If you add the two together, what are you going to get? So if you add the two together, just follow the note systematically. If you add the two together, what are you going to get? That's what I'm about to do now. So if you add everything together, we are going to have 3 into brackets s squared plus y squared plus z squared 1 plus half, that will be 3 over 2 minus 3 into brackets s squared plus y squared plus z squared raised by 3 over 2. Everything all over s squared plus y squared plus z squared raised by 3. So therefore, if you subtract this from this, you are going to get 0 all over. That's what you are going to get. This will equal to 0 over s squared plus y squared plus z squared cube raised by 3. Therefore, the square u, the x squared plus the square u, the y squared plus the square u, the z squared is equal to 0. Because if you do this now, this is going to give us 0. And this is what we are asked to show. And that's what we have shown. So for you to be able to get this correctly, just make sure that you follow the lecture. You follow the lecture religiously, step after the other. We are going to get what we have on the board, which is equally important. So it's very simple and straightforward. That's another example under partial derivative. So we have to note that when you are differentiating partially, you assume other variable to be constant. You only concentrate on the one you are given. Thank you.